Hello everybody, this is a video about like terms. I am your host Mr. Shirley, the Mathosaurus Rex. Now, our learning goal for today is to consider some methods for simplifying algebraic expressions, okay, which is a fancy way of saying making them just a little easier and a little easier to do things with, okay? Now, like terms are terms that have exactly the same variable portion. Okay, and we'll show a few examples here. So here are some things that are like terms. All right, so 5a, 3a, negative 2a are like terms. So they all have the same variable portion, which is the a. Right? Hopefully that makes sense. The coefficient in front, the number in front, does not matter as far as like terms go. All right, so similarly, 4, 15, negative 3, and 10 are also all like terms in that they don't have a variable portion. They are just numbers. Okay, and in that they are like terms. So 4a, 3n, 2, 6z squared are unlike terms because their variables are different. Okay, they are different letters, or in the case of 2, there is no variable. All right, 5n, 3n squared, and 7n cubed are also unlike terms, okay? Because for like terms, the variable portion must be exact. They cannot have different exponents to them, okay? Now, if everything was an n squared, for example, then those could be like terms. If it was 5n squared, 3n squared, and 7n squared, those could be like terms. All right, but that variable portion and exponent, if there is one, have to be exactly the same. All right, but again, the coefficient doesn't really matter. Okay, now like terms can be added or subtracted to simplify them. Which is, you know, again, to make them look a little nicer, all right? To make it easier to do math with them, to solve equations, things like that. And when you add and subtract like terms, all you do, so 5n plus 3n, is you add the number portion. You add the coefficients together. So 5 plus 3 is 8. Hope everyone's good with that part. And then you just rewrite the n. Okay, so 5n plus 3n just equals 8n. Okay, so you just add those up. Now, often in questions of this type, you will get several things mixed together. And it's important that you only add together or subtract, as the case may be, the things that are the like terms. Okay, so in example number 2 here, which says 5a plus 3 minus 2a plus 1, you've clearly got some things that are like terms. Okay, so the 5a and the 2a are like terms. And of course the 3, I'm going to put their lines on top just to differentiate them a little bit. The 3 and the 1 are like terms in that they don't have a variable. Okay, so you've got two different things that are the like terms there. So 5a minus 2a would equal 3a. Okay, hopefully we're all good with that. You just do the math with the number portions, keep the variable the same, and 3 plus 1 is 4. Surprise, surprise. Okay, so that would be your answer there. And again, 3a and 4 are not like terms, so there's really nothing you can do with them as far as adding and subtracting go. All right, and the third example here, hopefully you'll notice right away that these are not like terms, so there's actually nothing more you can do to make that simpler. Okay, unless you happened to know what x and y were equal to, which would make it more of a question similar to what we did early in the algebra unit with substitution. Okay, now just one quick note, you can multiply and divide unlike terms. Okay, so we could do things with them if we were needing to multiply them together, all right? But that is not the purpose of this video, so I'm not going to do that here. I just want to make note of it that you can. All right, on we go. I want to just do a slightly different way to think about terms like terms and adding and subtracting like terms. Okay, so we're going to use an example of our friend Tim here, who has 5 oranges and 3 apples. Okay, just bear with me on my metaphor here. If he found 4 more oranges, what fruit does he have now? Okay, so we've got 5 oranges, and then he found 4 more oranges, so plus 4 oranges. and he's still got the 3 apples, all right? And what he has now with fruit is 9 oranges and 3 apples. But of course, we can't combine the oranges and apples. Okay, we wouldn't. You could, I suppose, say he has 12 oranges and apples, but that would be less helpful and that would wreck my metaphor, so don't do that. But you would not somehow try and, say he has 12 orange pulls, or try and somehow combine those things. He's got 9 oranges and 3 apples. They're different things. All right? Now, one more question with that. If he found 2 more apples, but lost 2 oranges, what does he have? Okay. Oh, and apparently I went back to the original question. So 5 oranges minus 2 oranges, because he lost 2 oranges. All right. It doesn't really matter the order you put them in as long as you do the correct operations with them. Okay. And he had 3 apples from the start and found 2 more apples. So that's plus 2 apples. Okay. So that equals 3 oranges plus 5 apples. All right. If I've done my math correctly there. And I did. Thumbs up for Mr. Shirley. Now, again, it's important that, hopefully I'm using fruit here as an example of things that would be like terms. So oranges would be like terms, everything involving oranges, everything involving apples would be like terms, but you cannot combine them when you're adding and subtracting. Okay? Now, one last slide here. I would like you to pause the video and try these out on your own. Okay, I will assume you did that. And just again, I'll use my kind of pen tool here just to hopefully highlight some of the like terms. So 5x and 3x are like terms. 2a and 7a are like terms as well. Okay, so when you're doing them, you should do the 5x plus 3x, which equals 8x. Okay, and then negative 2a plus 7a, remember the a's you don't need to consider as much as you're doing the adding or subtracting. So negative 2 plus 7 should equal positive 5, so plus 5a. All right. This last one actually has 3 different terms because we've got a's and b's and a few numbers that don't actually have any variables with them. So those are just the coefficient part. Okay, so you need to treat them separately. And one note here that we didn't talk about as much, but if you see just a letter, you would want to treat that as having a 1 in front of it. Okay, so B would be the same as 1B. All right, which looks like the pound symbol a little bit, but it's meant to be 1b there. So when you see plus b and plus b, that's kind of like 1b plus 1b. Okay, you just don't often write 1b. You can, it's not wrong, but often people don't. All right, so to start with our terms, so 6 plus 3, wait a second. How did I arrive at that? Okay. I'm questioning a couple of some of my math here. So I have messed up one small thing, but I'm right on the rest of it. So that should not be a 3. Let's get rid of that. This should be a 9 because, as everyone knows, especially Mr. Shirley, 6 plus 3 should be 9. All right, and then negative 2a minus 8a should be negative 10a, and 1b plus 1b would equal 2b. Okay, and then because each of these 3 things are not like terms compared to each other, there's no more math that we can do with that at the moment. Okay, so hopefully that made sense. Hopefully you can get around my mistake right there. So please ask me questions if you have any during all the normal ways we do that. Try out the work that I've sent, and thank you very much for watching. I hope you have a wonderful day.